This is my cat, and this is the 3D avatar I generated for him with AI. From a plain AI-generated model to a fluffy, super cute little piggy, the secret was already hiding in the model's color texture map. Next, I'll show how I explored 3D animal fur and how I discovered and used this texture map. Once the inputs were ready, it took me only about a minute to automatically generate 200,000 strands of 3D fur.
Whoa, that is insane.
Hello everyone, I'm Fan.
I'm Xiaoyao.
As of 2026, AI seems better and better at generating 3D characters. It can recover shape and color, but when I put this model next to my real cat, the difference is still pretty obvious. Look, our little piggy originally has a soft outline around his cheeks, a fluffy tail, and this little belly pouch, all so cute. But on this smooth model, those features all disappear. To make this 3D avatar look more like Piggy, we have to grow the fur back onto him. Okay, so my first idea was really simple. Just grow fur straight on the model surface, straight out along the normal. Take a look at the result. Technically speaking, yeah, I grew fur, but it looks a lot like a dog and not a cat, and it is totally unnatural. Even after I comb the fur on the face, it is still kind of weird. And the funniest part is that after a bunch of experiments, I realized this idea is just Blender's built-in particle hair growth logic. So why does this most direct approach get the fur wrong? Because animals have a huge amount of fur. Do you know how many hairs an animal can have? A million. And they don't just grow outward. On the cheeks, back, legs, and tail, the direction keeps changing. Fur length and density also change the animal's silhouette. If the direction is wrong, it turns into spikes. If the length and density are wrong, it loses its original shape. So the real hard part isn't generating lots of hairs. Anyone can generate hairs. What matters is making them all follow one continuous, natural growth pattern. Of course, in Blender or any other software, artists can create and comb guides by hand to build a fur flow. But what I want to solve is exactly this: how to avoid grooming everything from scratch and let the model get a reasonable fur flow automatically. So I started looking for existing solutions. I originally thought there should already be a mature method for this, but after actually searching, I found literally zero. Compared with human hair, public research on 3D animal fur is shockingly scarce. Within what I could find, there was no public data set that includes both fur direction and 3D strand structure. Among the few related works, the closest to my goal is a NeuroFur paper, but when applying it to our AI-generated model, on my machine, it would need a GPU at 100% load for about 5 days just to run 5,000 strands. That is terrible cost performance, mainly because it relies on
3D Gaussian splatting
for inference, and the early results are also hard to control. What I need is a lighter pipeline that can start from an AI 3D animal model and is easy to repeat. Alright, next is the core of our algorithm, and I completely developed it myself. This algorithm can be split into 3 steps. Step 1. Find the fur growth direction. As I said at the start, the secret of growth direction is in the color texture map. Look at this map. See the texture. And what we really need is the direction of that texture. So I use image processing. First, estimate the texture direction at every location on the map, and also estimate the probability that it is fur. Then we project those directions back onto the 3D model surface through UVS. That way, fur that used to explode outward can start flowing along the body. But this can go to the other extreme. It is completely flat against the body, which also isn't right. Animal fur still needs a little lift off the surface. So finally, I combine the surface normals with the fur flow from the texture using vectors. Then it has both the right orientation and a natural lift away from the body. That is step 1. Step 2. Direction alone isn't enough. I carefully observed my cat's face and body. On his face, especially the triangle around the nose, he needs tight, short fur. The body needs longer fur. And around the eyes, there shouldn't be any fur at all. So I use 2 simple masks to control this. The first mask controls whether fur grows at all. Areas like the eyes and mouth get no fur. The second mask controls fur length in different regions. In this mask, white means a face region with shorter fur, and black means a body with longer fur. But we still need a natural transition from short to long. So green is a transition zone. It interpolates from white to black by distance. Now we have fur length and fur direction. Finally, we decide where to grow fur. We also have to consider computer performance, so we can be a bit clever. On the face, fur is short, so we sample more densely to cover the skin well. On the body, fur is longer, so we can sample a bit less and still cover it. We can also bring it back into Blender for some internal interpolation. In the end, we automatically sample root points, place the strands there, and adjust the length. Then we export the result into 3D software or a real-time engine. Once the model textures and masks are ready, generating these 200,000 strands takes only about a minute. That means I can quickly tweak fur length, density, and growth regions, then regenerate right away. I export the file as ABC format, and we can keep grooming and adjusting the fur until we're happy. And finally, we get our little piggy woo, that belly pouch. Look at that chubby face, so cute. So this is our first little animal that grew fur. This experiment started with my cat and ran successfully. Next, I'll test this method on more animals, different body shapes, growth directions, and fur length. In later videos, I'll keep researching fur, how to control flow, length, and density more accurately, and how to make it actually move.
Could that texture map become interactive? Like I draw a strand on the map bam and it grows out.
Hey, I think that is a great idea. We can try it later. Alright, that is all for today. If you found this helpful, please like and follow us. See you in the next episode. Bye!